Factor trees. What is a factor tree? A factor tree is a special diagram where we find the factors of a number, then the factors of those numbers, etc. until we can't factor anymore. The end of the factor tree presents all the prime factors or the prime numbers of the original number. In order to complete our factor trees, we need to know our prime numbers. So let's have a look at our first 5 prime numbers. First prime number is 2. Our second one is 3. Third one is 5. Fourth one is 7. And our fifth one is 11. So let's have a look at an example of constructing a factor tree. Now, to construct a factor tree, all you need to do is know 2 numbers that multiply the number that you're looking at. So if we look at 48, we need 2 numbers that multiply together to equal 48. Now, there are heaps of different numbers that multiply together to equal 48, and whichever number you choose will work. So I'm going to choose 12 and 4. So 4 times 12 is 48. Now that I have 12 and 4, I ask myself, are 12 and 4 prime numbers? No, they're not prime numbers. So that means I have to factor those numbers now. So if we start with 12, what's 2 numbers that multiply together to equal 12? And we have 3 and 4. Okay, is 3 or 4 a prime number? Well, yes, we know that 3 is a prime number, so we're going to put a box around that. Is 4 a prime number? No. So we'll come back to that one. Let's have a look at the other 4 over the other side. What 2 numbers multiply together to equal 4? So we have 4 and 1, but in factor trees we can't use 1. Okay, so what other numbers multiply together to equal 4? 2 and 2. Okay, so we draw little lines out like trees and we write 2. Okay, is 2 a prime number? Yes, it is. So let's put a box around it. And we just have one number now that doesn't have a box around it, and that's the 4. So which numbers multiply together to equal 4? 2 and 2. And then they're prime numbers, so we put boxes around them. And that's it. I have all of the numbers at the bottom of my tree now have boxes around them. So I have all of my prime numbers. Now I write that, and I'm going to write, well, if I was to look at the prime numbers that multiply together to equal 48, I would have 48 equals, and I just list these numbers. 3 times 2 times 2 times 2 times 2. And that's it. Let's have a look at another example. So this time we're going to create a factor tree for the number 80. So we need 2 numbers that multiply together to equal 80. Now you could do 40 and 2, or you could do 8 and 10. I'm going to do 8 and 10. So 8 times 10 equals 80. What 2 numbers multiply together to equal 8? 4 and 2. So we'll go with 4 and 2. And what 2 numbers multiply together to equal 10? 5 and 2. So let's put boxes around any prime numbers. 2 is a prime number, so I can put a box around that one. 5 is a prime number, so I'll put a box around that one. 2 is a prime number, so I'll put a box around that one. Is 4 a prime number? No, so I can't put a box around that one. And that means I have to factor that number further. So what 2 numbers multiply together to equal 4? And we have 2 times 2 again. And we know that 2 is a prime number. So for 80, the prime numbers that multiply together to equal 80 are 5 times 2 times 2 times 2 times 2. And that's it. Let's have a look at one final example. So let's construct a factor tree for 150. What two numbers multiply together to equal 150? There are a few different options, but I'm going to go with 15 and 10. So looking at 15, what two numbers multiply together to equal 15? And we have 3 and 5. And what two numbers multiply together to equal 10? 2 and 5. Let's put boxes around any prime numbers. Is 3 a prime number? Yes, it is. Is 5? Yes, it is. 2? Yes, and 5 again. So all of the bottom of my tree are prime numbers, so I can't go any further. So I can say that 150 equals 5 times 5 times 3 times 2. And that's all of my prime numbers listed. And that's how you do factor trees.